How's it going, everyone? In today's video, we're going to learn how we can create this tray and this cube with a hole in it in build123d using Python. About a week ago, I bought a 3D printer and I've been very excited to use it. And obviously being able to use Python to design objects is really cool. So today we will create these two simple objects. And as I learn more about build123d, we will move on from these onto much more complex objects. So let's get started by opening up our code editor. And you can use whichever code editor you like, but for this video, I'll be using Zed, which is also today's sponsor. Zed is a lightning-fast code editor written in Rust, and I've been using it to do all my coding for a while now. I really enjoy it for how fast it is and how simple it is. If you feel like trying out Zed, I've left a link in the description box down below where you can download it for free. Otherwise, let's get started with designing the tray and the cube in Python. Now, the very first thing you need to do is open up your terminal and either pip install or uv add build123d. And the very first thing we're going to do is create a module. And this module will be called export123d. And you can actually call this module whatever you like. I just thought it would be fun to stay on theme. But this module will take care of exporting and previewing our models. And I do want to mention that this will be Mac specific. So to make this work on Windows, you're going to have to search that on Google. But I will tell you which parts are Mac specific. So to get started, we will import subprocess, and from build123d, we will import compound, export gultf, and export step. Then I will create a function called export, which takes an assembly of type compound. It also takes a file name and whether we want to preview the model. If preview is set to true, which it is by default, we will create a glb file or a glb file and export it. And here, this is the Mac specific part. I will use subprocess to close the preview window if it's open, and then I will use subprocess to open the file. This is the only snippet you need to replace for Windows. These are two lines that close the preview window and then open the file, because I don't want a million windows with the same file being opened. Otherwise, below we're going to produce a step file. So here I set up the name, then I export the step assembly with the step file name. And at the bottom, I print that the step file was successfully created. So that's all this module will do. Being able to preview your model is not necessary for this tutorial, but I find it quite beneficial because I like to see what I'm creating. Anyway, now we can go to main.py, and here we're going to import everything from build123d, and we're going to import export from export123d. Generally, I'm really against using the star import, and the build123 docs do address this, but they don't seem to have an alias that they tend to use as a convention. So for this tutorial, I'm going to use the star import, but maybe in future tutorials, I will find my own alias. If you use build123d, I'd love to hear your thoughts about this in the comment section down below. Otherwise, let's get started by creating an item tray. So here we're going to define an item tray function, which takes a length, a width, and a height. And you can also change these to X, Y, and Z if you find that to be easier to read. Personally, I really like being able to see length, width, and height. And here we have the thickness, which will tell Python or build123d how thick we want our box to be. The asterisk here forces thickness to be a keyword argument, and this whole function will return a part. Inside here, we will start with build part to create our 3D object. And inside, we will create a rounded rectangle. And we use with build sketch here to create a 2D sketch of it, which we can later extrude to give it a height. And we will extrude it immediately under, and the amount will be set to the height. Now, personally, I hate writing a lot of code without showing any results. So let's try to print this part as soon as possible. We're not done with it, but I want to show you that we can preview it. So at the bottom, we're going to assert that the part_context.part is not none. And then we're going to return it. We still didn't use the thickness for anything, and that's because we did not finish writing the function. So here we can just type in to do. And below, we're going to create another function, which will be called prepare assembly. and this will return a compound. Then we can create a tray, which will be of type part, with these dimensions. And we will give this tray part a label. Then we can create an assembly, which will be of type compound, and this will equal a compound. And here the label will be set to tray, just for now, and the children will be set to the tray part. And we will return the assembly, which in this example will be formatted to a single line. Under that, we will create our if name is equal to main check and the main entry point. Here we will create an assembly, which will be of type compound, and we will define this to be prepare assembly. Then we can export using export123d, the module which we just created, to export the assembly, and the name of the file here will be set to tray, and we will set preview to true. I know it's set to true by default, but this makes it easier to understand whether we want the preview or not. And honestly, I'm going to make this a required keyword argument. So here I will add an asterisk, because it's quite important that the user knows they're generating a preview or opening a preview. But now we can run this, and on Mac, it should automatically generate a preview for you. As you can see here, I have a beautiful Mac Mini, which has been widened a bit. But essentially, all we did here is create a 2D shape, which is at the top. Then we used extrude to give it some depth. So that's all that we did here. Next, we're going to create another build sketch, which is going to end up becoming a smaller Mac Mini, which we will subtract from the original Mac Mini to make it hollow. So once again, we need a rounded rectangle, and the length will be set to the thickness times 2. Or it's not set to the thickness, but it's subtracting the thickness times 2 by the length. This ensures that the length is smaller than the original cube or the original rectangle. And we will do the same thing for the width, and we can set a radius to be something such as 7. Ideally, you would generate this number dynamically based on the original radius, but in this example, we're going to manually set it to 7. Then we're going to extrude once again, and this time the amount will be set to the height minus the thickness, and the mode will be set to subtract. And that's actually all it takes to create a tray. As you can see, when we open up the preview, we have a beautiful tray here, which is upside down. And at the moment, I'm still very new to build123d. So I don't know if there's an easier way to flip it, but for the time being, all I did is rotate it on the x-axis by 180 degrees, so that when we render it, we end up with an object that is sitting upright. Now below this, we're going to create a cube with a hole in it, which might not be as interesting as a tray. But the reason I'm doing this is to show you how we can create an assembly, because it's easy to generate one part and print it, but to generate several parts and print them together does require this extra setup. And the export function is well equipped to just export a part, but honestly, for now, I think it's better if we make it accept compounds, because inside a compound you can define a single item. And if you change your mind later, you can always add more parts. That's why I'm not processing single parts here, only assemblies. Now going back up to the cube, it's time we use the context manager with the build part. And this time we will create a box, which will have the dimensions of 20 by 20 by 20. And below the box, we will create a cylinder with a radius of 5, a height of 20, and the mode will be set to subtract. Then once again, we're going to assert that the part context.part is not none, and we will return the part. This always returns an optional, so by asserting it is not none, we help out the static type checker. And again, I'm still new to build123d. If you know of an easier way to return a part and not an optional part, please let me know in the comment section down below. Otherwise, let's move on to prepare assembly, because in here we need to define a cube, and we can call this cube part, which will be of type part, and that will equal a cube. The label will be set to cube, and now we can go to the assembly and change the label to tray and cube. And this time the children will be set to the tray part, and we will give it a position modifier, which will move 85 millimeters on the x-axis, and we will multiply this by the cube part. And the reason we're doing this is because I want the cube part to be pushed slightly to the side of the tray part. Otherwise, the cube part will be generated directly in the center along with the tray part. And before we run this, I want to change the name to tray and cube. And now we can run this. And what we should get as a result is a step file which contains a tray and a cube. And the file looks like this. As you can see, we get what I showed you at the beginning of the video. 2 separate parts which we can print anywhere that a step file is accepted. So the last thing to do now is to find the file and drop it in Bamboo Studio, or whatever you use to print your 3D objects. Now, as you might have noticed, the cube is still floating here. So what we're going to do is right-click on the step file and scroll down and locate split. And what we want to do is split this to objects. Once it registers them as separate objects, it will place the cube down. And then using A, you can rearrange the setup, and these are now print ready. If we click on preview, we'll see exactly what the objects will look like, and we can zoom through the process using this slider. And just like that, you learned how to build your very own parts using build123d. My recommendation here is that you play around with this script. Personally, I changed the dimensions of this tray to 160 by 40 by 15. And I also changed the thickness to 2. As a result, I created a tray which held my tools for my 3D printer, which was quite convenient. And if you don't care about the cube, once again, you can remove that and remove it from here as well. And now this will generate only one item. As you can see here, I have my tool tray, which is quite cool. So yeah, that concludes this tutorial. Do let me know what you think about all of this in the comment section down below. Otherwise, we're going to continue learning how we can use build123d to create cool custom objects that we can later print on our 3D printers.